Hey everyone, welcome back to another episode of Career Tea. I'm your host Sohrab, and today I'm excited to have a special guest, Sean Heinze. Sean earned his bachelor degree in microelectronic engineering from RIT and has built an impressive career working in semiconductor manufacturing, first at companies like IPG Photonics and Skyworks Solutions, and now he's a hardware development engineer at Apple. In this episode, we'll explore his journey from his early days in engineering through his hands-on internships and manufacturing roles, and then focus on what it's like working at Apple today. Sean, welcome to Career Tea. How are you doing today?
Doing good. Thanks for having me here. Excited to be here, help out the podcast, and hopefully impart any knowledge and experience that I have to your viewers.
Of course, it's great to have you here, Sean. And you're on West Coast time, correct?
That is correct.
So I'm on East Coast. You probably have a much nicer weather there than us. Probably sunny, warm.
Yeah, it's sunny, warm, bit rainy right now, but it's good. It's good. We need the rain.
Nice, nice. So let's jump right in. So I want to start from your early days at RIT. You studied microelectronic engineering at RIT, and that's a field about, I'm assuming, circuits and innovating devices, right? So one thing that I want to learn a little bit more about is what microelectronic engineering really is, right? I'm sure a lot of like young, students kind of going into college, they might not necessarily know what microelectronic engineering is. You hear about engineering, electronic engineering, but microelectronic, I personally didn't hear about it. So I want to know about what it involved as, undergrad studies, and then also what drew you to kind of choosing that specific area of engineering at RIT.
Yeah, sure. So microelectronics engineering, a lot of people might know it to be related to the chip industry. Otherwise known as semiconductor industry as well. They actually, RIT is a bit of a unique situation where it's one of the few schools that actually offer this as an undergraduate degree. I think when I started around 2012, it was one of maybe three schools that offered it for undergrad. And so it's very niche. A lot of people don't know about it. Actually, I didn't even know about it when I was looking at going to college at the time. I was actually more interested in electrical engineering during that time period. So it's kind of looking around for electrical engineering schools. RIT was one of them that I was looking at. And when I did my visit, I actually was introduced to the dean of the microelectronics engineering program after being referred by one of the electrical engineering professors. And the dean actually gave me a quick window tour of their lab.
Mm-hmm.
And essentially, it's kind of what you could imagine, people working in a clean room, wearing suits to keep the particle counts very low in those clean rooms. So essentially, I got the window tour. The dean was kind of giving me a quick overview of what it was. He was saying it's very physics heavy, very chemistry heavy. You do a lot of, you have some aspect of electrical engineering work in there as well. So it's kind of a broader space of like you kind of dabble in a lot of different fields versus just being a bit more focused in one discipline. And that piqued my interest quite a bit because through high school, I was always more preferential for mathematics and sciences. And this kind of seemed like it would be a better fit in terms of that. So yeah, that's kind of how I got into the microelectronics engineering program. That and I mean, soccer helped too because I was also looking for soccer at the time. And RIT was a D3 school, so one of the places I could play soccer. Not athletic enough for D1.
So it worked out perfectly. You could play your soccer there and then continue down the engineering journey as well. You said RIT was one of the few schools that offered microelectronic engineering. Do you, by any chance, I mean, I know it's probably a long time ago, but do you remember what the other schools were that at the time were offering those programs?
Yeah, so for undergrads, I believe it was just RIT, SUNY Albany, and Purdue. There's tons of other schools that offer it as graduate programs or even PhDs. But yeah, for undergrad, RIT was really one of the few.
Do you think it's probably grown to a bigger size? Do you think that might have been just back in the day, or you think it's still a rare undergrad program?
In the US, it's still pretty rare, in my opinion. Granted, I'm a little out of touch with what universities are offering nowadays since I don't really look. But I believe it's still pretty low frequency in terms of the number of schools that offer this as an undergrad degree. Purdue is actually, from what I've heard, is expanding their undergraduate program for this. RITs is more or less the same size, just less funding of a school for the school and smaller than Purdue, of course. But yeah, that I think it's more of a general lack of funding from the U.S. as well, because these programs are very expensive to have at a school. Essentially, it's a multi-million-dollar project to build the facilities that you need to be able to teach these programs and also maintain the equipment. You need to pay people to maintain the labs themselves. So it's overall very expensive, and the government in the U.S. just doesn't fund it as much. However, if you look at places like China, Taiwan, Japan, there's a much larger emphasis in this industry, and they have a lot more undergrad programs than the U.S. So
I usually ask my guests later in the episode regarding like their advice for younger students. But since you said, a lot of schools offer this degree as a graduate degree, if somebody was interested between, let's say, electronic engineering or another engineering versus, microelectronics, would you suggest to them to go down this route only because it might give them a edge and a kind of getting started earlier? Because I guess if somebody was to go down that route, they would have to wait until a graduate degree. But if they go to RIT, they could kind of start earlier, and after graduation, they almost have a experience that a lot of people have to go to graduate school to get that.
exactly, and I know it's kind of tough to be thinking about that, especially during your high school years, because at that age, like I said, for me, for example, I didn't even know what the industry was in high school, and only when I went to college did I know. However, if you do know about it and you're interested in the semiconductor industry or the chips that go into a lot of our technology nowadays, going to a school like RIT for this degree specifically is a huge advantage compared to those who start out electrical and then later figure out that they want to go into this degree. You just get that much more of a head start. And quite frankly, when I was at RIT, a lot of the coursework that I did was with the other graduate students. So in a sense, you can argue you're just getting that much more of a head start on those that didn't take that as an undergrad. However, I will preface if the microelectronics semiconductor industry is still pretty tight-knit, small in the U.S. So just for those that would be interested, it is an area where you're a bit more restricted in terms of where you could work. Just because electrical engineering, you can work almost anywhere in the U.S., but semiconductor, you're pretty restricted to larger cities like Boston, DC, Dallas, Austin, and Silicon Valley are probably some of the biggest named cities that I can just think of off the top of my head right now. There's a few more, but just not as versatile as electrical engineers.
Makes sense. And that's probably because of the space that's required for them to have, right?
Yeah. It depends on where the technological innovation's happening. So Silicon Valley, of course, is a big one. Part of it is also, if you're more on the manufacturing side, land costs and space. So actually, I left this off the list accidentally, but Phoenix actually is starting to bring in a lot of large manufacturing facilities for companies like TSMC and Intel.
Makes sense. You mentioned the coursework that you were doing undergrad. It was with a lot of graduate students, which kind of leads to my next question. For students that are kind of maybe starting out in microelectronic engineering or are hearing this and are like, okay, I'm kind of interested. What was some of your coursework like, right, during the 4 years? And we don't have to go in detail in all of them, but what would you say, like, some of the exciting parts of your coursework and what were some of the challenging parts of your studies during those 4 years, right? To kind of give a better understanding to students of, what they might deal with during those 4 years. And I know a lot of coursework probably starts out more general in the beginning and kind of gets more specific during the 4 years.
Yeah. So, exactly as you said. During like years 1 and 2, it's pretty general coursework. You probably share a lot of the coursework as other engineers that have similar disciplines. So all the physics and mathematics courses are pretty general. Then you start getting into general circuits courses, and things like that, which you'll start sharing with like other electrical and computer engineering degrees. And then probably year 3, 4, and if you're in a 5-year program, year 5, you start getting a lot more into very specific coursework for the microelectronics engineering degree. And they are very much material science, physics, and chemistry focused. And then on top of that, lab work, because a lot of what we do is essentially applied physics, applied chemistry. So that's really where you start to differentiate, and where it could start to get a bit more complicated. I mean, we all know physics is hard,
And chemistry.
and chemistry, yes. And it can get a little funky in terms of the concepts that you're trying to understand. It's hard to visualize. It's not like mathematics where you have the numbers in front of you and you're trying to work them out. But yes, conceptualizing, visualizing what exactly you're trying to do in those material science programs and other physics, chemistry-based programs can be a little challenging. But that's where the labs come into play quite a bit. Like I said, that's where you actually apply your knowledge. And RIT did a really good job of that. We had a lot of lab work, a lot of lab time, and we also had something called the Senior Design Project at RIT at the end of our 5th year. And all of that is essentially applying everything you've learned through all of those material science, physics, chemistry courses into those types of projects and lab work. And it really helps with the visualization, conceptualization of what you're learning.
Yeah. How does, if you don't mind explain a little bit more, how does, I guess, chemistry and physics, because like somebody that's from engineering background, I hear that I'm thinking more science. How does that kind of fit into, I guess, engineering, especially microelectronics engineering?
Yeah, so for microelectronics engineering, the whole premise of it is essentially you are making these tiny circuits or even photonics devices, photonics being like light emitting devices. And all of that comes down to a physics chemistry backbone. So usually you're starting with some kind of base material. So a lot of people will hear about silicon nowadays. There's other sectors besides silicon. There's sectors called 3-5 compound semiconductors, a bit different. You require different chemistries and processes in order to make devices out of those, but more or less similar concepts. But yeah, as far as the physics aspect of things, when you're making these electrical circuits or chips or devices, whatever you want to call them, they require a sequence of there's, I guess, main pillars. There's lithography, which is patterning. There's etching, which is removing material in order to sufficiently pattern your device. And then there's also things like deposition, which is you're applying insulated materials or conductive materials in order to create your electrical circuit, essentially. And all of that is from physics. So like etching and deposition, you have something called you have plasma systems, and essentially how you generate that plasma is all physics, right? Similarly, there's other things like wet etching, which is chemistry based. So you have to know what chemicals will etch the materials that you're trying to pattern, essentially. So in silicon, you'll typically you'll need to know a lot about like bases. So if people are familiar with acid bases, usually use bases to etch silicon, or you use acids to etch things like oxides. And those are all materials that are on the semiconductor device that you're trying to fabricate. And I know I can lose a lot of people here because it gets very complicated. And if you're not familiar with this field, you probably have no idea what I'm talking about. But yes, in order to fabricate these devices, it's all physics, chemistry, and applied material science knowledge. So that's really all it is.
Would you say that, I guess, we didn't really touch too much about, like, I guess, the challenging part of your studies. Would you say that could potentially be where a lot of challenges come up from, is when it gets into, I guess, physics, chemistry, and goes in detail in those subjects?
Yeah, exactly. Yeah, just understanding the basic principles of how they work is kind of where it gets pretty challenging, where you can lose a lot of people. On Honestly, I'll say my education has helped give me the foundation that I need to understand those a little bit more easily once I've joined the workforce. But a lot of what you learn is ends up being on the job anyways. Honestly, I think what I've learned on the job has been way more valuable than kind of what I've learned in school.
Makes sense. So before you started your full-time roles at RAT, you did have a couple of internships, right? You gained some valuable hands-on experience through Rudolph Technologies, if I'm pronouncing that correctly. So I know you supported customer demos and helped improve manufacturing processes. And in your other internships, you worked on getting new products ready for production and testing them to ensure reliability. So I want to learn a little bit more about your first and second internship. I know I kind of just touched base on it at the high service level, but what were the differences in those two internships? Would you suggest similar type of internships to students? And do you think they kind of got you ready for when you were ready to go into like full-time professional work?
Yeah, so the first internship I went into was actually for applications engineering. That one was at Rudolph Technologies. And applications engineering is essentially a mix of understanding the customer requirements and the process behind what the customer is asking for. So Rudolph at the time, they're more known for making metrology equipment for the semiconductor industry. However, there was one subsector which I got involved in, which was the lithography industry. And essentially, those are multi-million-dollar systems that are used to pattern very small features onto the silicon substrates or whatever substrate that the customer is using. And so that was really nice because you kind of are involved in in everything. In a sense, as an applications engineer, you need to know about the process, you need to know about the equipment that the company is selling, and then you also need to know how to interface with customers and understand what the customer is requesting out of your equipment. So it was a great marriage of those three, and I think that was kind of a nice first step into my internship world, just because it was a very good exposure to all three of those, which are very valuable for my industry right now. Now, Microsemi, actually, they've recently changed to Microchip. They're no longer Microsemi. They made all sorts of chips for like defense sector, some consumer electronics, but defense was a big one for them. And for that, I was actually a product engineering co-op, so quite a bit different than applications engineering. Product engineering is very much knowing more about what types of devices the company is making and how to get them from a design phase all the way up to a prototyping phase. And then the next step after that would be the high volume manufacturing phase. So you're essentially kind of, in a sense, babysitting the product through each one of those phases and kind of supporting the smooth transition from design to prototyping to manufacturing. And that was kind of nice because you get a bit more of a higher level overview of how those products move through the company, what types of quality checks, electrical checks, or testing checks that you need in order to say, hey, this is the design, we're ready to go to prototyping. And you've kind of gone through all the potential failure modes and effects that could happen as a result of that. And then you kind of try to weed that out in the prototyping. And then the prototyping, it's very small volume, right? It's not nearly ready for manufacturing. So as a product engineer as well, you kind of go through with other processing engineers, other quality engineers, and you try to figure out how to make it ready for high volume manufacturing. So yeah, it involves a lot of collaboration with other engineering teams. It's less involved on the processing side. It's just more involved on the high level, like test data understanding and quality understanding. So that's actually quite different than what I do right now. So right now I'm very much on the processing side. So a lot more hands-on. Product engineering, again, more hands-off. So it just depends on what someone's interests are as far as which one of those realms you might want to kind of dive into. But yeah, both were very good. I mean, I think it made me a much more well-rounded engineer, since you kind of see what it's like being in those different roles versus kind of being siloed to a single role in processing or a single role in applications. You also kind of get to understand what are the challenges with each of the roles, and what are the challenges in terms of like how you can communicate with other applications engineers or other product engineers. So yeah, I think it's been pretty good in terms of just my general communication with interdisciplinary engineering teams. Um, and yeah, kind of what the expectations that they're looking for when me as a current process engineer, just kind of what I need to do in order to kind of achieve the metrics that they're looking for.
Yeah, makes sense. And I was going to ask you whether those internships kind of influenced you one way or the other, kind of telling you, hey, am I on the right path? Do I kind of like this? But from
Yeah,
my understanding is that it did give you an idea, whether you liked it, whether you like some aspects of it or not, you kind of got a broader experience and exposure. And you kind of, you said what you're doing now is not necessarily what you were doing during those internships, but it's one way or the other, it's kind of led you to this path. So I'm sure you gained a lot of valuable experiences from those.
exactly. Yep. And you never really know what you want until you try them all. And fortunately, internships, you're not committed for too long. So definitely try the stuff that you're wondering, oh, what's this like? And if you don't like it, just switch to something totally different.
Yeah, I think it's always better, honestly, to try something and you don't like it, because I think it's better because to find out what you don't like, because you can just kind of cross that out, right?
Hmm.
Versus like kind of liking something, but you're still not sure. But if you don't like something, perfect. Like now you can kind of just put that aside or go a different path.
Exactly. Yeah.
So after your internships, you moved into your full-time roles, first starting at IPG Photonics. You worked as a process engineer managing important steps in making semiconductor lasers. And then later on, you moved on to Skyworks Solutions, working advanced to senior process engineer role, where you were overseeing high volume of manufacturing processes for transistors. I want to understand more about those two roles, one of them being your first job out of internships. Kind of in your internship phase, you're kind of in a learning phase, learning environment. Now you're going into your first professional experience, more responsibilities. What was that first role like? And then moving on to Skyworks Solutions, where I assume you took more of a leadership role, and now it's your second job. So I want to understand, your first job to your second job, what are your responsibilities like, and kind of the transition between the two as well.
Yeah. So IPG Photonics they're a high volume manufacturer of laser diodes. Skyworks, they are also a high volume manufacturer, but different industry. They are in the 3-5 compound semiconductor transistor industry. So a bit different. But yeah, when I came out of college and joined IPG Photonics, it was a very challenging yet valuable learning experience. Challenging in the sense that manufacturing is not very forgiving. You really need to ramp up quickly. You need to ramp up the learning curve pretty quickly. You need to really start making impact pretty much from day one, right? And there's a lot of expectation by management in terms of how committed you are, how much effort you put in, things of that nature. So yeah, I mean, it was very valuable in the sense that like I learned kind of what the feel of high volume manufacturing was like. I learned how to work quickly, efficiently, and also maybe not so nice is that you do end up putting in a lot of hours of work for a manufacturing environment, and that's ultimately because whenever there's an issue with the manufacturing line and production stops, that's essentially money down the drain for the company,
Yeah.
in addition to time being lost, right? So really, there's a lot of stress to kind of get things working again. So yeah, I mean, IPG Photonics, again, it was really interesting. So you get the challenges of the manufacturing environment. It's a bit of a smaller company in the sense that there's fewer engineers in a smaller engineering team compared to other behemoth companies like Intel or Samsung, right? But it was also kind of a blessing in a sense because I had a lot of exposure to a lot of different processes and equipment. So instead of like a high volume manufacturing company like Intel, where you come in as a processing engineer and you have one role, you own one set of equipment. At IPG Photonics, I had my role, but I actually owned a huge sector of the process. I essentially owned like 50% of the process and 50% of the equipment. and they were all different disciplines. So as I may have mentioned earlier in the podcast, there's kind of different pillars of how you can fabricate devices. There's lithography, etching, deposition, just to name a few of them. And I was pretty much involved in all of those. Versus if you work at a company like Intel, you might be involved in either like lithography alone or etching alone or deposition alone. Quite different. I became a more versatile a more versatile engineer with broader experience in those. And so that's kind of why I would think that it was a bit of a blessing working at IPG as my first job. Just because I think I kind of leaped ahead a lot of people in terms of my the experience and kind of learnings that I had across different modules within the semiconductor industry.
Yeah, it kind of gave you that grit. Yeah, that grit and hard
Yeah,
work.
you
Yeah.
get the grit. Yeah, exactly. Yeah, that place definitely gives you a lot of grit. It's yeah, you go through a lot of stress, a lot of long days. High volume manufacturing in general. Just expect to have more hours than you would in other types of roles like R&D. It's faster pace. It's ultimately where the money is for the company, so it's
Yeah.
high stress in that sense. So that's kind of the expectation that I would have going into that environment, but it's also rewarding in a lot of ways too, because you know that you're making a very direct impact to the company versus R&D. You never really know if your projects pan out, right? And if they don't pan out, then you're really not making any money for the company. You're not kind of seeing the value of your work. But yeah, so pros and cons in whichever direction people want to choose. But yeah, high volume manufacturing is tough. But yeah, and actually, I wanted to touch on the second point that you asked, which is Skyworks.
Mm-hmm.
So Skyworks, I moved up into a senior engineering role. I think that was about 3 to 4 years out of college when I joined Skyworks. So still a relatively junior level engineer in the overall number of years of experience, but I was able to gain that senior title pretty quickly because of the broad experience that I had at IPG. Again, IPG, they kind of just throw you to the wolves and you kind of learn it pretty quickly. Think of it as like an accelerated 3-year learning curve to get to a senior level engineer at Skyworks. And then Skyworks was a lot more of like the same in terms of the intensity, the number of hours you're dedicating, and essentially what you're trying to output, which is a more efficient working process. But it was kind of nice making that move because I also had what came with kind of the senior title was I was able to collaborate with some engineers that they didn't report to me. They actually reported to my boss. But I kind of required their help and support in a lot of cases. So I kind of help train them up on certain processes. I teach them how to execute different engineering experiments, things of that nature. So it was pretty beneficial in terms of assisting my workload, and also just nice to have a team that can support you versus IPG. It was pretty much just me doing everything.
Yeah.
Yeah.
Makes sense. And from you telling your stories, I can tell that even though you said IPG was kind of throwing you to the wolves, that was it was a blessing and a curse, but it was, it gave you the necessary foundation to kind of be successful later on down your career. Which kind of leads to my next question about, for somebody who's interested in semiconductor manufacturing, or like a student right now in school or going to school, what would you say is like the most important skill or mindset to develop, which I'm sure we could have picked up from your stories, I'm assuming like having grit, hard work, but what would you say, like 1 or 2 words about a skill or mindset that they should kind of have or try to develop during their, years of schooling before they go into full time?
Yeah, sure. The number one thing I would say is just having having a good sense of adaptability to your environment and what you need to accomplish. Having clear goals in mind in terms of so when I joined IPG, right? I've seen a couple of different cases of people coming through and leaving. You have some people that come in who just straight out of college, right, that have trouble adapting to the environment. the stress of the environment, have trouble adapting to the pace, especially the engineering work in itself, like the theories, the concepts, they're not that hard to learn. But at the end of the day, you need to put in the time, and how much time you put in early kind of dictates how quickly you advance through the industry. And some people just didn't quite adapt to that and kind of had a slower learning curve, put in a little bit less effort at the start, and ultimately suffered in the industry and moved on to other roles. But yeah, adaptability is really the number one thing, I would say. And then having kind of inherent sense of learning things quickly is really good too. But yeah, I mean, from a more technical standpoint, general problem solving skills, knowing how to identify a problem, knowing how to execute test plans, is very valuable. And while it sounds simple, it can be pretty complicated depending on the application, and semiconductor industry is no easy application. So it's very, very heavy on the applied physics and chemistry. So
I bet.
um,
Yeah.
good engineer and kind of scientist minded person is very valuable.
Yeah. I was gonna say the adaptability point I like because, like you said, a lot of jobs like you do learn majority of the skills like on the job, versus kind of in school. So having being able to like adapt to the work environment, because like when you go to work, you might think like you're expecting one thing, but it's gonna be completely different. So being able to kind of shift your mindset and adapt to your current circumstances, I guess that's huge. Being able to, because that will essentially help you be able to learn fast, kind of get over that learning curve. So yeah. Which that kind of leads me to my next point of, you've gone through, the grit, the hard work, the stressful times, which led you after that to your current role now at Apple, one of the biggest companies known for its innovation, high standards. Majority of us have Apple, iPhones and other Apple devices. So now I want to learn a little bit about your day-to-day responsibility, what it is like to be a hardware development engineer at Apple. Kind of, yeah, what your day-to-day is like. I understand that you may not be able to really talk in details about projects that you're working on. But I guess from a high point of view in general, what does a hardware development engineer at Apple kind of deal with on a day-to-day basis?
Yeah, sure. Yeah, so yeah, Apple's a huge company, of course. We're all familiar with it, and their engineering is broken up into a bunch of different sectors. So for the hardware side specifically, there's hardware engineering and then there's hardware tech. I actually fall into the sector of hardware technology, which is focused very much on the development of it. Well, in my case, I should say, might not be necessarily the case for all of hardware tech, but in my case, it's the development of future technologies that we eventually want to consider for our products. Right? Unfortunately, I can't divulge what types of products those are and what technologies exactly we're working on. But that's essentially the sector that I fall in. And as far as the day-to-day goes, it's different than everything that I've done in the past. Everything I do now is much more research and development focused. What I used to do was all manufacturing, right? So manufacturing, you know exactly what you're making, how all the processes that need to go into making it. And essentially the focus ends up being more in terms of reducing manufacturing costs, making the manufacturing process more efficient. Right now, we're making stuff that's totally different, totally new, and it's challenging in the sense that the direction is not always clear, and what you need to do in order to be successful at your job is not always clear. So you're kind of making good engineering decisions in terms of trying to develop a process that might work for this product, but might never be realized at the end of the day. So it's a bit of a guessing game in some respects, but it's very fascinating because being in this realm of hardware technologies, it's all cutting edge technology at the end of the day, versus what I was doing in the past, which is less cutting edge. It's just newer technology. It comes with new challenges, and you just kind of pray that it works and that maybe one day we'll see it in our products.
Yeah. Do you think that when you look kind of back to your beginning of your journey, let's say your first internship, did you ever envision yourself being at a tech giant like Apple? Did you ever have this end goal, or do you think your path kind of guided you here?
Yeah, interestingly enough, I when I first joined the industry, I never thought I would be at Apple. Yeah, Apple is known for their hardware and their software, but they're not necessarily known for manufacturing.
Yeah.
Apple outsources a lot of its manufacturing to manufacturing partners elsewhere. And so, me being very heavily involved in the manufacturing industry for the semiconductor industry, um, uh, just Apple was not really an option that I thought of at first. I thought maybe the end goal would eventually be companies like Intel or TSMC. Well, maybe I shouldn't say Intel now because they're going through their own problems, but TSMC for sure, or like other big name companies in my industry like ASML. Those are all kind of the behemoths of our industry, and kind of where like the top of the top go. Now, Apple, it was kind of fortunate in terms of how Apple's been progressing their technological innovation. You've probably seen it on the news if you keep up with their hardware tech stuff. They are starting to do a lot more in-house development. And sometimes what comes with that is some level of in-house manufacturing as well, in order to prototype these devices before they can go out to a manufacturing site. And with the timing of when I was looking for a new job at the time, it kind of worked out that my program within Apple was looking for an engineer suited for my experience. So yeah, a lot of it was timing. And
Worked out great.
yeah, it worked out great. Honestly, it was a bit of a Hail Mary because for me, I only have an undergraduate degree. I don't have a fancy master's or PhD degree, which I know a lot of those larger tech companies like to see in an individual. So it was a Hail Mary, but
It
before I
worked
knew
out.
it, got the word that they wanted to interview, and it all kind of worked out, and the stars aligned just right for this role.
Yeah, and I'm glad you mentioned, having like master degree or the fancy degrees of having graduate degrees, because it's nice to see that, you didn't necessarily have a graduate degree, but you've landed a amazing job and at a tech giant like Apple, right? So for students that might be kind of curious about this path, a lot of people think like, oh, in order to land at, let's say, Facebook, Google, Apple, you need like graduate degrees, master's degrees. So it's nice to see that, that's not necessarily the case. There is, pathways that you could make it to these positions, to these companies without having those master's degrees, especially in times like this now as well, where the economic times, it is tough. Having a master's degree doesn't necessarily guarantee you, landing at a big company. But out of curiosity, Apple's iPhone has been leading, I guess, the phone industry for so many years. And every few years, we see some company come out with their phone, Google or Samsung. They come out with their phones, and people say, oh, this might beat Apple. But I feel like iPhone's always kind of still like leading the way. I know you might be biased towards this question, but do you think there will ever be a company or a phone that will come out that people will shift towards, away from iPhone? Because I feel like majority of people are still on iPhone, even though the people do use other phones, but I feel like iPhone users are still majority of the people.
Yeah, that's a great question. I mean, I guess for my own personal gain, I hope everybody continues to use iPhone and sticks with iPhone. But yeah, I mean, it's tough to say. I mean, I think Apple makes a great product. It's very. They also have kind of developed a network where, I guess you could argue, it's hard to get out. Once you're in, it's hard to get out of.
The
Um,
blue messages, is that what you're talking
exactly.
about?
Blue messages, yeah. And also just the features of the phone are great. I mean, they're always putting in the latest and greatest features. No, I I understand that maybe people want to see a bit more diversification on the phone. I'm sure things like that are being worked on. I don't work on that myself, so I can't really speak to it. It's just all my own speculation. But yeah, I mean, I see it being tough to topple Apple with the market share that Apple has. and it'll definitely take some time. I feel like the only way Apple could kind of stumble is if they made some mistakes down the road. But at the moment, I don't really see that. The management's doing a pretty good job. They know how to appeal to the masses. If anything, I'm actually more curious to see how other products in industry play out, right? Because even companies like Google, Meta, they're all big into AR, right? So AR might be a big sector that eventually a lot of companies want to get into, and you see some products already that have been prototyped and out in the market that people like that Meta, for example, might be claiming is a replacement eventually for a phone. So it's pretty interesting to see if how that sector kind of plays out, and if they can make something that's actually a phone killer um, more so than just trying to continue to advance the phone technology
Yeah,
itself. So
makes sense.
yeah.
Cool. And so I have two more questions for you before we wrap up. The next one you might have an answer for, you might not. But I usually ask this from my guests. It's regarding whether you have a book that you would either suggest to, the listeners, or if it's a book that you've read that you really liked. This could be for pleasure, or it could be maybe something that helped you within your work, past internships. So is there any type of material that you read that you either enjoy personal time or that kind of helps you with your professional work?
Yeah. Yeah, I'm not big into reading like professional development books. Personally, I'm actually a bit more nerdy in a sense that I'll read more like technical articles, or research papers, or I like to kind of keep up with current events, current latest technology releases, things like that. And those all kind of help me in terms of my own professional and personal growth. Like the technical papers kind of keeps me up to date in terms of what's the latest and greatest in terms of what people are doing for my job. And then, yeah, current events, and I like to read other kind of like economical papers, just kind of keep with the market, and yeah, that's more for my own personal growth.
Yeah, no, I think that's a great suggestion, especially for students or anybody in your field. Kind of from understanding, reading articles, new releases on different technologies. It kind of helps them kind of staying up to date and staying ahead of the curve, I guess. My next question and my last one is, we kind of touched on, your advice for students, but to kind of wrap it up and kind of put it together for students that are going down the same path, or young professionals who might be in engineering, maybe a different field, maybe in microelectronic engineering, or maybe even somebody who wants to end up at Apple, right? What practical advice do you have for them? One, I guess, regarding what they should do on their day-to-day work, right? And as well as kind of what skills, certifications they should develop to kind of be as successful as they can be, right, in their field.
Yeah, sure. Yeah, so my number one thing that I like to point to is ultimately industry experience. That's kind of how I got to where I'm at, is just developing the right type of experience. So as I mentioned earlier, I was kind of exposed to a lot of different things early on in my career, specifically within the semiconductor industry. And a lot of that past experience has kind of, it's ultimately what has allowed me to move into different roles, more advanced roles, and ultimately what led me here at Apple. I definitely don't have the educational merit that maybe other people would have. However, I do come in with a good number of years of experience within my role, and that's kind of my biggest advantage. You also need to understand how to work with people, how to communicate effectively, and how to interview. Interviewing is always very critical. If you can't convey what your background and what your experience is and how you kind of tackle different engineering problems, it's pretty tough to get a job. And whenever you're doing engineering interviews at big companies, a lot of what they'll ask you is about your engineering experience. Yeah. And so, yeah, that's always going to be the number one values experience. As far as other things, I would say never settle in terms of what you do. don't kind of get comfortable in your role and just say, oh, I'm just going to keep doing the same thing for years and years and years. Always look for new opportunities and kind of show your worth. At the end of the day, how much experience you get ends up coming down to what kind of projects you find for yourself once you're within the roles. Don't always expect your manager or your manager's manager to give you your projects. You do kind of have to be a go-getter and kind of look for what situations you need to engineer out a new solution for, right? And I mean, the other thing I would point out, while it's not necessarily always under your control, your managers end up being a very vital support mechanism for how you kind of develop through your career. You always want good managers. If you're ever stuck in a situation where you have a bad relationship with your manager, I recommend getting out of that ASAP. You always want good managers who will have your back, who will be willing to give you a challenging project so that you can excel. So yeah, in that sense, just never settle and never kind of be stuck in a bad situation. Always try to look for new situations where you can continue to be challenged and excel in your career.
I like it. And I guess what I take away from it is kind of being proactive in every situation, whether it's in your company, being proactive to kind of, getting new projects, helping out where it's needed, outside of your work, being proactive to find new opportunities. And always, I guess, realizing your current situation and circumstances and moving forward.
Exactly.
Well, Sean, thank you so much for sharing, these practical advice as well as sharing your journey with us today, from your early days at RIT through your roles in semiconductor manufacturing to your current role at a big giant like Apple. Your insights into the industry and your practical advice for students and young professionals. It's very inspiring, and I'm sure that our listeners will take something away from it, and hopefully it will lead them to a company, a role that they enjoy. Maybe one of them will become your coworker at Apple. So who knows? So I really appreciate your time today.
All right. Yeah. Thank you very much. It was a pleasure chatting with you.
And that wraps up the episode today for Career Tea. If you enjoyed our conversations, please subscribe if you haven't. Leave a comment, leave a review, and share this episode with anyone who might be in the same field as Sean, who might be interested there, or they might already be in early their professional career, and they might be inspired and take something away from this story. And as always, leave a comment regarding if you're interested to hear about a different field, different profession, and we'll try to find somebody in that field as well. Thanks for tuning in, and we'll catch you guys again next week.